The ice canopy theory and why it is wrong. If you are unfamiliar with the foolish ice canopy theory, let us have Kent Hovind himself explain it to you.
I think when God made the earth, there was a layer of air, maybe 10 miles thick, a layer of crystal and probably crystalline canopy above that, and then outer space full of stars, and then another crystalline canopy of ice. There used to be a seventh layer, water above, probably ice, above the atmosphere. A couple inches, 3 or 4 inches of ice. I didn't know, nobody knows, it's all gone. Some of my old seminars say maybe 20 or 30 inches of ice. We don't know. But I found a reference that the Jews had taught at the time of Christ that it was 3 fingers thick. Now, how did they know? I don't know. It's gone. But a layer of water or ice above the earth, and your question here is, how could it be held up? Excellent question. Well, super cold objects, super cold magnets, there's a magnetic effect called the Meissner effect. A magnet will float on top of a super cold object. Liquid nitrogen, for instance, becomes a superconductor, and a magnet will float. So, and they're finding lots of ice clouds, and the space shuttle goes up, it leaves ice crystals behind, and they drift to the poles. They become magnetic. This is a picture from Walt Brown's book. His hydroplate theory, I think, is spot on. Water underneath would go shooting up as the Earth cracked up along the current plates that we still have. The San Andreas Fault, the Hayward Fault, where Earth's all busted up like an eggshell. The water would go shooting out so fast under, say, 10 miles of rock that the pressure would probably launch things into orbit. A cubic foot of rock weighs about 160 pounds, depending on the kind of rock, of course, 140 to 180. 10 miles of rock would put 8.5 million pounds of pressure per square foot. That's a squirt gun. That's about 30 tons per square inch. At 30 tons per square inch, once that water finds a way out through that rock, because the rock is cracked, it's going to shoot things into orbit, escape velocity, 25,000 miles an hour. I think during the time of the flood, stuff went shooting off of the earth. Couldn't prove any of this, just my theory, okay? Give me a break. Shot millions and millions of rocks, all different sizes, up into space. As the crust of the earth came unglued like an eggshell, broke into pieces. Then we keep going around the sun, and the moon keeps going around the earth, and the two of us together start running into all this debris that got launched off. And it'll float around in space till something smacks it like a bug on a windshield. And that could be the reason why the moon opposite sides of the moon have different crater patterns. The side we see has great big craters on it. The other side has more even smaller craters. They're the ones that shot out, turned around, and came back because of the moon's gravity. I don't know. I believe there was an ice canopy or water of some form, probably ice, above the atmosphere. My theory is that you're objecting to. There used to be a seventh layer, and I believe it was ice above the atmosphere. Let's see, we don't need that. There was a crystalline canopy of super cold ice 10 miles above the Earth. It might have been 20 miles up. So I believe an ice canopy could be held up either simply by air pressure or by magnetism, or maybe a combination of both. I don't know. It wasn't there and it's gone. It's just a theory, but I don't think you poked any holes in it today. We know that super cold ice is magnetic. The Meissner effect. Here's a fact that ice is diamagnetic can be demonstrated by hanging an icicle from a very thin string and bringing a strong magnet near it. The icicle will twist away from the magnet. So, let's quick review. The Earth has a magnetic field. Super cold ice is magnetic. Okay? Hovind theory. Earth had a 10-mile thick crust with a 2-mile layer of water under it. That's my theory. Then had a layer of air, maybe 10 miles thick, for us to run around and breathe in. Then a 3-inch layer of ice held up by air pressure or by the magnetic field above the firmament. So anyway, the fountains of the deep broke open. The water went shooting up to the top. I mentioned before, a cubic foot of rock, depending on what kind of rock, weighs about 160 pounds. 10 miles of that stacked up would weigh a whole bunch and put 30 tons per square inch on the water underneath. When it finally gets a crack to shoot out of, I think it would launch rocks into space. Certainly launch them up and shatter that canopy, and that canopy, being super cold ice, would be drawn to the poles magnetically. So when the fountains of the deep broke up, I think it would launch rocks up and shatter that canopy.
Kent Hovind claims he taught high school science for 15 years. Someone should have taken the same time to teach him properly.
I believe there was an ice canopy or water of some form, probably ice, above the atmosphere.
Space isn't a freezer, it's a vacuum. In direct sunlight near Earth, exposed materials become very hot. Even icy bodies like Halley's Comet lose material rapidly when near the sun. Solar heating causes sublimation. An ice canopy only a few inches thick would absorb sunlight daily, warm above deep freeze temperatures, turn directly into vapor in a vacuum of space, gradually erode away. Over 1500 years, it would not merely thin, it would disappear.
We know that super cold ice is magnetic.
Supercold ice, being magnetic, conflicts directly with basic physics. Ice is not magnetic. Ice is diamagnetic, meaning it is very weakly repelled by magnetic fields. It is not attracted to poles. Kent Hovind showed a slide where it was explained, but he seemed to have trouble to see that it actually contradicted his theory of supercold ice being attracted to the poles. Or maybe he just doesn't know the difference between magnetic and diamagnetic.
The fact that ice is diamagnetic can be demonstrated by hanging an icicle from a very thin string and bringing a strong magnet near it. The icicle will twist away from the magnet. The fact that ice is diamagnetic can be demonstrated by hanging an icicle from a very thin string and bringing a strong magnet near it. The icicle will twist away from the magnet. There's a magnetic effect called the Meissner effect. A magnet will float on top of a supercold object. Liquid nitrogen, for instance, becomes a superconductor, and a magnet will float.
Here Kent Hovind is being either ignorant due to a lack of knowledge about the Meissner effect or deliberately dishonest. The Meissner effect is the expulsion of a magnetic field from a superconductor during its transition to the superconducting state when it's cooled below the critical temperature. This repulsion will repel a nearby magnet. Materials that can be superconductors include pure metals, metal alloys, ceramic copper oxides, ion-based compounds, certain exotic molecular materials. Some theoretical work predicts that ice could become superconducting at extremely high pressures. One prediction is superconductivity around 1.8 Kelvin if ice is compressed to about 5 terapascals, tens of millions of atmospheres. That is far beyond what occurs naturally on Earth. Using the Meissner effect in an attempt to validate the ice canopy theory, hard fail. An ice canopy would drastically alter Earth's radiation balance, producing extreme greenhouse or anti-greenhouse effects. An ice canopy would trap outgoing infrared radiation and it would also block sunlight. A solid planetary scale layer would be an extreme alteration of the radiation balance. An ice canopy would create a severe energy imbalance, cooling from reflection, heating from trapped infrared. The system would not remain stable. It would shift toward either rapid warming if infrared trapping dominates, severe glaciation if reflection dominates. Even small changes in an atmospheric composition can significantly shift global temperatures. If there was an ice canopy above Earth, the thermodynamic system would not remain stable over centuries.
So when the fountains of the deep broke up, I think it would launch rocks up and shatter that canopy.
To get a rock from Earth to the Moon, it must reach Earth's escape velocity. Water jets, even hypothetical superjets, cannot do this. The fastest natural water jets on Earth reach hundreds of meters per second. Needed to reach space is 11,200 meters per second. If water on Earth were accelerating rocks worldwide that fast, a significant part of the atmosphere would be lost. Heat large portions of the crust beyond melting point. Oceans would be partially or largely vaporized. Anything accelerated to those speeds at a near instant would experience extreme compression heating, vaporize or melt. That is why rockets are streamlined, launch gradually at carefully calculated speeds, use heat-resistant materials. Random rocks in a water jet would never make it through the atmosphere intact. Here you can see what effect a speed of 26,700 km per hour has when a space capsule is re-entering Earth's atmosphere. Think about what effect a speed at escape velocity would have. And this is in the upper part of the atmosphere, where the air is thinner. Fluid flow has three hard limits. Jet speed limited by pressure-density relation. Objects in the flow cannot exceed the fluid velocity. Turbulence and breakup destroy long-distance acceleration. A water jet exiting into air at extreme speed will explosively expand, atomize into droplets, lose velocity very fast. This is basic free jet instability. Solid rock is much more dense than water. Water wants to go around solid heavy objects instead of staying under it and push it. The atmosphere would destroy the jet. A supersonic water column emerging into air would expand, atomize, become turbulent almost immediately. The required pressure can't be stored in the crust. Rock near the surface breaks at about 0.1 to 0.3 gigapascals. The jet would require about 63 gigapascals. The crust would fracture and vent long before that pressure accumulated, so the system self-destructs before it can charge up.
There was a crystalline canopy of super cold ice 10 miles above the Earth. It might have been 20 miles up. So I believe an ice canopy could be held up either simply by air pressure or by magnetism, or maybe a combination of both. We know that super cold ice is magnetic. So when the fountains of the deep broke up, I think it would launch rocks up and shatter that canopy. When it finally gets a crack to shoot out of, I think it would launch rocks into space. Certainly launch them up and shatter that canopy. And that canopy, being super cold ice, would be drawn to the poles magnetically. It's just a theory, but I don't think you poked any holes in it today.
Yes, we did. Not only a hole, it was ripped apart. We understand that many years of holding to this theory has rooted it deep into his narrative, so it might be both mentally and physically impossible for him to disregard it now. These explanations to why the theory is wrong might encourage him to expand his knowledge and understanding of the world of science and physics. But we do not hold much hope for that.